Hello, everyone. Welcome to the monthly webinar of HiveMQ. And this month we are talking about smarter manufacturing from data chaos to real-time data intelligence, unlocking the operational excellence with advanced data management. And I'm Ravi Subramanyan. I'm the Director for Industry Solutions for HiveMQ. And I'm very, very glad to be joined by Kudzai, Manditereza, who's the Senior Industry Solutions Advocate. Kudzai, say hi to our audience as well.
Hello everyone. Thank you so much, Ravi. We're really looking forward to talking more about real-time data intelligence today. So
Awesome,
great to be
awesome.
here.
So I'm going to be talking for the first few 20 minutes or so, and then I'm going to hand it over to Kudzai, who's going to be talking about some new product announcement in this category, and and we're really excited about this, and we're looking forward to making this a very interactive session. So if you have any questions, please shout it out, and let's enjoy this 1 hour and make this very informative for all of us. So this is kind of like the agenda, right? I mean, the promise of smarter manufacturing. What are some of the problems that we face with this around this data chaos as we see it? How distributed intelligence, and I'll obviously talk about what it is, can help overcome some of these challenges. How like a technology like MQTT or Unified Namespace provides that foundation for distributed data intelligence, and then some of the use cases and benefits, and then I'll hand it over to Kudzai to talk about Pulse and some of the use cases and so on and so forth. All right. So that's the agenda. And we have already introduced ourselves. Sorry. Yes. Okay. So again, the vision of smarter manufacturing, right? I think we started with smart, but now we are even smarter, right? We're getting smart, smarter, smartest. I think it keeps going, right? I think that vision is that increased efficiency, reduced downtime, improved quality, greater agility. You as an manufacturing individual, you might have operations within your plant or across multiple plants or different locations within your plants. How could you make sure that you're able to overcome some of the challenges that you have with inefficiencies because maybe some sections are efficient, but other sections are not? How do you make sure that as the data flows through, as the operations come together, you're able to kind of like have that same level of efficiency? How can you predict the failures of some of your machines? For example, we show like these robotic arms. How do you make sure that that doesn't just like stop like in the middle of your production schedule, right? Ensure that you have improved quality of your output of the whatever you're manufacturing, and also like have greater agility. Suddenly you have like this extra load or extra orders that you get. How do you make sure that you're able to react to it and do it really fast? That's kind of like that challenge, right? How do you break the data silos, overcome legacy systems, and the inability to see the data in real time and achieve your end results? So again, when you look at the data chaos, jumping a little bit more into it, the data deluge is all about the explosion of data. I think manufacturing is, if I'm not mistaken, it's the number one source of data generated more than anything else because you have all of these different systems like sensors, machines, ERP systems, and other applications, databases that are generating millions and millions of data, right? That are exploding. And unfortunately, these systems are totally disconnected and isolated. You have like the operations technology systems, if you will. You have the information technology systems on this side, typically more on the enterprise and on the cloud, and they're disconnected. Or even if they're connected, they're not connected in a robust manner. There's no context. Even if they're connected, there is no context around the data. So when you try to like bring all the data to the cloud, for example, or to the enterprise without doing anything to the data, and then you expect it to then start like using it for decision making, it's not there. The context is not there. Meaning like you don't know what that data is, where it came from, what is that, how do you use that data effectively, and things like that. And that leads to like delayed insights because you don't have the data in real time. Yeah, and that leads to consequences like suboptimal performance, reactive maintenance, missed opportunities, things that you leave on the table. And then looking at like the solution, right? I mean, distributed data intelligence is all about, the traditional manufacturing often involves funneling all the data to a central location with not much processing, maybe to a cloud or a data center for processing, and then you kind of like take the data and then you do something with it. Maybe you spend like a few months massaging the data. Now the issue with that is twofold, right? One is like ingress costs of cloud solutions are extremely high. And B, it's like you have a lot of this data. All of this data, this manufacturing data, if you just move it to the cloud without knowing which data is useful and which is not, it's hard to sift through. It's almost like searching for a needle in a haystack to figure out like which is the effective data. So that becomes a big issue, right? So while effective for some kind of analytics, it does create like latency issues because you're moving all of this data. So you create latency issues. It may not be real time. And you obviously exacerbate some of the data chaos that you have in the operational front. What distributed data intelligence it does is that it helps you overcome this by enabling intelligence without really forcing the data to move to a centralized cloud or a data center. Meaning, like, you can actually derive intelligence with data that is present wherever it currently is. And then that ensures that the data movement is minimal and only like the right data gets moved or the process data or the contextualized data gets moved to the enterprise so that like when you start processing the data using the power of the cloud, you can actually develop more powerful applications and more powerful use cases in a more efficient manner. So looking at DDI, we'll call it DDI going forward. Um, so it's kind of like an agile and efficient paradigm. So again, data acquisition at the source, eliminating data silos, which is basically you have these edge devices that are intelligent, that are able to talk to all of these different data sources. You're able to then start standardizing data right at the source and not wait until the data gets to the enterprise. So, hey, what format do I want to start looking at this machine data? How do I kind of like ensure that as I collect the data, it is starting to be standardized in that right format so that when it gets to that next level, maybe to a plant level, and as you're consolidating data at a plant level or at an enterprise level, everything is kind of like a build on. So the contextualization that happens at the edge kind of gets built on. And then you can have like a centrally contextualized set of information that you can then use for whatever you're trying to do, right? And this also allows you to do a lot of the edge compute right at the edge because now with the power of technology, you have a lot of like compute power right at the edge. So you can run some of your real-time and analytics and AI inferences right at the edge so that you don't have to do all the the processing on the cloud. This also enables you to reduce your latency because in a lot of applications, you need to be able to generate the insight right then and there because you need that immediate feedback loop so that you can fix some problem that might happen without having to wait for the data to go to the cloud or the enterprise, do some analytics and come back, by which time the event is already gone, right? Like a use case for that is like you're doing a vision system where you're capturing pictures of like your products, your finished products, or your maybe in like inventory coming through, right? You want to make sure that as it's going through, it is good quality. It didn't miss certain things. There's no foreign particles in it, and then you have to be able to do like analytics right then and there and decide, hey, is this good or is this bad? As opposed to waiting for the data to go to the cloud. And there are other use cases for that too. And it also enables like your strategic data routing and storage, as we talked about. How do you make sure that you're able to optimize your bandwidth and the cost? How do you make sure that only the necessary data gets to the cloud of the enterprise and the other data can just be wherever it is, but you can still derive insights from that? So that like this whole notion of if I want to derive insights, I have to move data is not always true. Yes, you definitely want to move data that makes sense, but in other cases, you can still derive insights while the data is where it currently is. It also helps you, like even from a cloud storage perspective, it helps you like manage your storage costs better as well. And looking at some of the technologies that enable distributed data intelligence, the first one is an MQTT broker. So again, just a way of quick introduction for those who don't know MQTT. It's an open source messaging protocol that started in the late 90s. And it started for oil and gas. It was created by two gentlemen from IBM, Andy Stanford Clark and Arlen Nipper. And this was specifically for Phillips 66, which is a oil and gas company. And they had like these upstream oil and gas operations where they had remote assets sitting in the middle of nowhere that really didn't have much connectivity or bandwidth. And they wanted to be able to do remote management of it for two reasons. One is like from a safety perspective, they didn't want to send personnel every time to the middle of nowhere. And even if they went there, they had to do one or two things, just flip a switch or do something that is very trivial. If only they could actually do all this like management or like at least monitoring remotely and only send people where it was really necessary for them to send. That was the goal. But again, traditional methods wasn't like suitable. So MQTT came along as a publish subscribe protocol that can work in very limited bandwidth, limited connectivity situations where if I'm a remote asset and I want to be able to send the data, I can publish the data whenever I have connectivity in a small packet, very lightweight, with minimal overhead to like a centralized repository, which we call a broker, as you can see here. And that broker is typically sitting on the enterprise with better connectivity. And then the broker can then share that information with other clients, maybe like a remote monitoring application or a database or some other application that needs that information in real time. Because now it's all event driven, exception driven. So whenever the information is available, maybe like a temperature value changed or a pressure value changed or some switch has been flipped to on, somebody needs to know that. So that can be notified right away and in a publish subscribe in a event driven decoupled manner, meaning like you don't have a spaghetti architecture where everything has to connect to everything. Everything has connects through like a broker, right? And it also introduced this quality of service that guaranteed delivery. There is persistent sessions and things like that. So that started in oil and gas, but soon got into manufacturing and other areas. And today it's one of the most sought after messaging protocol when it comes to moving data and consolidating information. So that becomes a very, very important part of distributed data intelligence. And the second one is what we call a unified namespace, which is basically an architectural design concept that kind of like revolves around like truly transforming all this data chaos into a distributed data intelligence. It basically serves as a context layer that sits on top of MQTT to create a single, consistent, actionable data source across the business, or in other words, a single source of truth. Now, you might ask, why can't the MQTT broker be that single source of truth? Absolutely, it can. But what it lacks is the context, right? It's not just about bringing all the data to one location. It's also about contextualizing the data, consolidating the data, bringing only the necessary data. For example, for me to do my operations, I need data from some of my machines, if you will. But I also need data from my MES system, which is a completely different system because some of the events around my manufacturing operations are there. I also want to bring my alarms and events from like some other location. Maybe I want to bring some product related information from my ERP system. I want to bring some information from my database to kind of like show me that single source of truth for what I want to look at. And then I want to take that information and like the semantic model that has been built based on all of this information coming together. And then I want to fuel my advanced applications, analytics, and AI, agentic AI, in a way that is effective. So the problem today with AI is that everybody talks about AI, agentic AI. It's fantastic, but when you ask organizations about why they're not being adopted, one of the biggest reasons that come out is the fact that they're not able to trust the data. So you can build these very cool models, but if the model doesn't actually produce the results that you're looking for, or worse yet, it gives you like the false results, and that is attributed to the data quality or the issue of like the data not being in the right format or real time, then that is a big problem, right? So this is where I think having this ability to build your hierarchy, semantic data model that contextualizes all of that information, ensures that your data is real time is absolutely important to ensure that when you try to run your AI models or different aspects of AI, you have all of this information in real time and you can trust the data and you can ensure that AI is adopted within the organization as well. So that's unified namespace. And this is kind of like a visual representation of what I just talked about, right? So typically it starts in the way unified namespace is organized in the industrial world is, and obviously like Kudzai will go into more details, is using the ISA 95 model of you start with your enterprise, you go to your site, which may be Munich in this case, you go to area, your line, and then cell. And then under your cell, you have all of these different events, alarms, things coming from your maintenance system, your MES system, some events and other things that are happening. So you can actually look at specific information like high pressure or low pressure, but it's actually like contextualized to that particular location. So you have your metadata being added, if you will, as you go through all of these different layers. And then you have your actual data. So a combination of the metadata and the data is the one that creates this semantic model or provides the context behind things that you want to do with this information. And as mentioned before, it's all real time. And like as this pressure data changes, high pressure or low pressure, you'll see that immediately and you can take actions from that. That's the concept of unified namespace. And then, like before I hand it over, I want to just talk about some quick benefits. And we touched upon some of these things, right? In the context of manufacturing, like the robots that you saw, the predictive maintenance becomes a very, very important thing. So it's all about sensors collecting data from all these critical machineries that you have within your factory floor or your maintenance location, or maybe if you have energy, your energy assets, or any industrial asset, for example. And then you're getting all of this high frequency data is getting consolidated into some edge devices that can perform some real time analysis, and the output of that is then being shared with other entities like enterprises. That allows you to do proactive scheduling of maintenance, prevents costly unplanned downtime. The second is like autonomous quality control. So again, we talked about this example of high resolution cameras and other sensors on a production line that are capturing all these images of the product as it's flowing through. That is then sent to like an edge AI system, which can be used to create some inspections that can produce results around which are good, which are not good. And so not only will you improve the quality of the product, but also it becomes a learning opportunity for how to ensure that from a process perspective we improve. Like for example, if certain issues keep getting repeated, why are those issues getting repeated? What are the things that you need to do in your process chain to overcome those things so that you reduce your waste, scraps, improve your product consistency, enhance your customer satisfaction, and so on and so forth. And the third is like dynamic production optimization. So again, it's all about ensuring that your overall equipment efficiency is high. And how you do that is by collecting like real-time information on machine utilization, throughput, material flow, energy consumption, which is absolutely important. It is kind of like a forefront for all of the things that you want to do from a sustainability perspective, for example, for a lot of companies, which then helps you improve your OEE, as we'd like to call it, help you improve your throughput, reduce your energy consumption, and then optimize your resource allocation. Last but not least, the smart grid management, for example, it's all about edge intelligence. And this is kind of like a repeated theme, right? So you want to kind of like empower right at the source of the data, in this case, maybe a solar farm or a wind turbine that has all these smart meters and substations. You want to add intelligence right there. It may not be as sophisticated as the intelligence that you have on the cloud, but some intelligence allows you to enhance your grid stability. You don't want to always have to depend on the cloud to be able to do that. You want to do some of that right at the edge, and you want to distribute that across your edge systems, if you will, in a way that will ensure that you are able to seamlessly manage all your renewable assets and reduce transmission losses and things like that. So that's kind of like this whole distributed data intelligence and how that is enabled by unified namespace and MQTT. And you might ask, like, hey, all these use cases can be done by sending the data to the cloud. But what you will miss out is the latency, right? The reduction in the latency by only allowing the right information to go to the cloud. The cost savings, as we talked about, cloud is costly. Why send the data to the cloud when you don't really need to, right? So there's a lot of cost savings. And there's also improved operational efficiency and productivity because you're able to do things quickly and not have to wait for the data to come back. So you're able to quickly do all this right then and there. And of course, reliability and resilience is also an added benefit as well. So that's that. And before I jump and I hand it over to Kudzai, I would like to play a quick video introducing our new HiveMQ Pulse, which is a next generation distributed data intelligence platform. So here it is.
HiveMQ Pulse is a next-generation distributed data intelligence platform, empowering businesses with real-time actionable insights. With a flexible architecture built on the power of MQTT and designed to support a unified namespace approach, HiveMQ Pulse unifies and contextualizes data across the enterprise for smarter decisions, exactly where they matter most. With HiveMQ Pulse, project teams can unify data management, with advanced cataloging, transformation, and governance for consistency across the enterprise. Gain real-time insights by acting on data in motion for better decision-making. And enable distributed intelligence, enhanced by AI and ML for smarter decisions at the source. We can help you manage, transform, govern, and derive insights from distributed devices and systems, even in resource-constrained and high-throughput environments. With HiveMQ Pulse, your IoT data is always accessible and optimized for impact, powering a unified namespace, delivering actionable insights, enabling distributed intelligence, and ensuring your data is AI ready. HiveMQ Pulse is now available in private preview. Join us in shaping the future of distributed data intelligence. Visit hivemq.com to learn more and apply today.
All right. Thank you again. And at this point, Kudzai, please take over and talk about this pulse that we've just primed for our audience.
All right, thank you so much, Ravi. Okay, so I'll kind of like continue off where, Ravi left off. I'd like to start to talk about, the opportunity, right? What is the, the opportunity that we see a lot of, companies losing, out on really having this robust data foundation, right? So these are kind of like the figures that have been, reported on by some analyst firms. So, for example, you see there's a whole lot of savings that could be achieved with the once you have the high data quality in place. Because for a lot of advanced analytics use cases, AI use cases, the biggest sort of like you know you know uh, in, sort of like issue that a lot of companies face as far as realizing benefit from that is the data quality, right? And secondly, the visibility of the data is also a very big sort of like challenge that a lot of companies face as far as getting sort of like return on investment from their data in the investments, and also just the ability to be able to sort of like make faster decisions is also a huge opportunity to really for organization to get from having a robust data foundation. So maybe let's kind of like get more into depth about the actual technical challenges that companies are facing as far as laying that foundation that really enables them to become a data-driven manufacturing company or industrial company as it were. So, I mean, the first big challenge, kind of like as I already alluded to, is this, data accessibility, right? Data is not accessible, and for a lot of companies, for you to be able to become a truly data-driven, organizations, you want to be able to access data across your entire enterprise in a format that is understood, also again across your entire enterprise. Secondly, Ravi mentioned this, you need to have some, governance in place, for because if the data is not really trustworthy, no one can really, utilize the analytics. So kind of like having, mechanisms in place to actually, determine who is the owner of the data and kind of like what are they allowed to do and what is the quality of the data and all the security that, goes with it is something that really needs to be backed into your data architecture from the word go. And then lastly, we've got this ability to be able to generate, continuous insights. So again, we spoke about this idea that, a lot of, companies approach that they take is to get the data, send it into, into the cloud. And as you may know, for those of you who are familiar with that data engineering pipeline, sometimes you've got this scheduled in like, 8 hour or 24-hour sort of like periods where you kick off that ETL to get the data from your shop floor into the cloud. So that's kind of like a really long time because if you are a plant manager on the shop floor, you need to have that data to be able to make, those minute by minute decisions, use data to make those, minute by minute decisions. You really want to be able to generate those continuous insights that help you, really improve, performance of your processes. So, we spoke about this, in a whole lot of material that we put out there. This idea that, for companies to be able to realize, that the ability to become a truly data-driven company, the first, prerequisite is really to move away from this, traditional approach of, data integration, which is, really as a result of the IS 95, functional hierarchy model, where you've got different network segments where different systems live in different segments. And what you end up having at the end of the day is kind of like this point to point architecture, where at each layer you've got like specialized system integrators that need to be there to be able to for you to kind of like integrate data from one layer. If you're moving from like your level 1 to level 2, there's a special sort of like dedicated connector that you need to be able to put together, and then also moving from level 2 to level 3 all the way up. So the kind of like this tight integration really makes it difficult to or really it takes long, and it's a costly exercise for companies wanting to sort of like de-silo the data and make it available across the entire enterprise. And then, secondly, again, we spoke about this data of accessibility, that in some cases where organizations are able to sort of like, establish some connectivity between different systems, even with that point-to-point architecture, you still have this data that is digitalized, but it lives in many different silos. So what a KPI in one system is not the same as a KPI in another system, right? A compressor is defined differently in another system. So there's no really standardization, there's no common format, there's no common access point for all the data. So you kind of like have all these um, data silos. And also, this is just hard to scale, right? If you're going to be making all these direct point-to-point connections from system to system, it's something that is really hard to scale from one line to the next, or from one factory to the other, factory. And also just, from the fact that once you have all this sort of like tightly coupled architecture, then you can't really guarantee, availability of the data. Because if you want to become a truly data-driven organization, you want to be able to trust that data will always be available whenever you need to make a decision. So, when with this tightly coupled architecture, when one system breaks, it affects, a whole lot of systems, and, and all that kind of stuff. So we've seen, companies sort of like move from this, proprietary interface, and maybe they adopt an open interface, say OPC UA, and but still you have this request response, architecture. So your system is distributed, but you still have this point-to-point interfaces. So really, the big aspect about really, getting yourself ready to become a data-driven company is to adopt a decoupled architecture, which is what this unified namespace really does, fundamentally, to kind of like break those point-to-point connections and then replace those with the central hub, so that all these different systems, and then Ravi spoke about this idea of a report by exception, where all of these systems, they generate data, all this data is published as events to that one centralized, platform. So what that allows you to do is that you're no longer reliant on having these specialized integration services each time you need to de-silo your data. You're not reliant on these, custom integrations each time you need to sort of like make data accessible. And also because you've got this one area where, or this rather one hub of information that is accessible across your entire enterprise, then the accessibility and the visibility of your data is greatly improved, which then allows you to be able to build analytics. And also, you want to use the data for whatever, sort of like objective you want to achieve. So kind of like, as we sort of like move more away from the unified namespace, not necessarily away from the unified namespace, but once you've set that, unified namespace, that, backbone for your architecture, then you're able to realize the power of the distributed data intelligence that, Ravi already introduced.
Hmm.
So what you see there is an architecture that shows you that edge to cloud, data backbone, as far as a distributed data intelligence architecture is concerned. So you can see that on the shop floor, you've got, HiveMQ Edge, which is a connectivity software that allows you to plug into your all different systems, whether they talk Modbus, they talk, it's a roll call automation system, or it's a flat file that you need to get data out of. So that piece right at the edge allows you to connect to all these systems, de-silo the data, and convert it into a protocol that is understood across your entire enterprise. And once that has happened, this data will then be relayed to the next level, which is your central broker that is typically at a site level, that is sort of like consolidating data from all these, HiveMQ Edge installations, and sort of like putting it into visible within a plant area. And then this could also be further propagated into your sort of like your enterprise, MQTT platform, your MQTT broker that holds data across your entire enterprise. And then that will kind of like make it easy for you to scale because what you do from one line, it's a matter of just having that, particular gateway that converts from your legacy protocols into an MQTT protocol, and then you're effectively reducing that into a kind of like, a plug and play. So as soon as you sort of like, commission a new line or add a new machine, automatically that gets published up into that central sort of like hub of information, and then it becomes visible, instantly, right? So that becomes easier for you to scale because you're sort of like plugging into infrastructure. You're not connecting application to devices or application to application. You're connecting devices and applications to an infrastructure. So that's kind of like really makes it easy for you to scale your solution across different systems, and also because you've got this central backbone where if one system goes down, it doesn't really affect because no system is directly dependent on connectivity with another system. So you only need to, connect to that one central piece. And also because, that central piece is more enterprise grade with all the clustering mechanism that, enables that, redundancy and make sure that you never lose any message or this really doesn't go down. So you always have that always on piece at the center of your architecture. So kind of like really just to summarize what HiveMQ Pulse is before we go into a more detailed architecture and then before I actually show you what that looks like, on the actual console. So this is again, to reiterate, it's a real-time distributed data intelligence platform that provides insights at the source, precisely where they matter the most, right? And then this kind of like speaks to the example that I mentioned to say if you are on the shop floor, you're concerned about the how quality is going, right? You don't want to sort of like get the data out into your IT. You want to be able to generate those insights right where you are so that you can get all of that data. And also if you are to send the data out into your cloud, you want to have a mechanism of first aggregate, because the reason why we send all of the data out into the cloud is that so that we can start to look at it from an IT standpoint and then start to make all these aggregations. But if you've got that capability or that intelligence that is distributed, you're able to sort of like filter the data, sort of like aggregate the data and massage the data, and then only send those aggregates up to the cloud. So kind of like let's talk about the capabilities, of HiveMQ Pulse, right? So again, we spoke about this idea of real-time events. So once you have that MQTT backbone that gives you real-time events, you've got the real-time visibility across your entire enterprise. And then we spoke about the idea of streaming governance. So with Pulse, it comes with sort of like data governance backed into that unified namespace. Because as you may know, for unified namespace, a lot of companies what they do is that they maybe have an Excel spreadsheet living somewhere, right, with no really governance that could be really enforced in any way. And then some depend on just the data that is flowing through the broker to know what data is flowing through that. So HiveMQ Pulse out of the box allows you to be able to provide governance about who is able to kind of like create a site, who's able to publish into what namespace and things like that. And more importantly, it maintains that data catalog, right? You've got that data catalog that kind of like gives you the ability to be able to have this consistent data format against which you can build queries to power your analytics and all the different kind of data-driven application that you want to build. And it also has historical, so it's not a historian, but it has an ability to historize some of the data, so kind of like keep this ephemeral storage to keep some sort of like events, maybe last 1,000 or last 100 events for you to be able to aggregate and get and generate those real-time insights at the edge.
Yeah.
And then this
Yeah.
really makes your data AI ready. Again, we spoke about this idea of the lack of context and the lack of high quality data. If you're
Mhm.
able to filter the data at the edge, if you're able to contextualize the data, map it into a namespace, and then simply query the data, you're able to that feed that directly into your, your LLMs or your classical AI or ML models that are able to, get all of this data in full context, whether it's for inference or you want to use it for training your AI models.
Yeah. Hey, just before you go to the next slide, just wanted to also reiterate that obviously you talked about historical analysis, and the natural question would be like, hey, can this replace my historian, or can this replace my current AI tool that I might have, Maybe I have Databricks, I have like Palantir or other tools. This is not meant to replace any of them. It is meant to augment them because obviously you have a lot of information that is being like generated or like data being generated on the edge, and you want to be able to consolidate all that information. And while consolidating, if you have a way to do some quick analysis before the data goes to a historian or other things, it's just the convenience that we offer on top. And then the output of that can then go to a historian or then go to an AI application, and then it'll be even more potent, right? I mean, we just wanted to reiterate that. Um,
Yes.
Kudzai, there was also a question related to Pulse. Maybe I thought like we can just address that. How
Yes.
much data can be managed by Pulse? Can HiveMQ Pulse handle like an offshore platform, meaning like I think offshore oil and gas platform collecting from that platform?
Yeah, so I mean, kind of like as I mentioned, the backbone for HiveMQ Pulse is the MQTT, right? So, and we've done several benchmarks as far as the kind of like data that could really be handled within an MQTT platform. So it really depends again on the sort of like resources, meaning hardware resources that you can make available for your broker cluster, right?
Mm-hmm.
And I think we did a benchmark where we had like 100 million concurrent connections, all publishing data. I'm not too certain on the size of the payload, but just the sheer amount of devices that are connected to one sort of like broker class at any given time. If there are 100 million, then you can kind of like get a sense of the scale of
Mm-hmm.
the data that you're able to handle with Pulse. So Pulse is a layer on top of that MQTT
Exactly.
backbone.
Exactly. So yeah, you have to have your networking layer, right, which obviously is able to bring in all the data from your devices. You have to have the messaging layer that adds that messaging context on top, and then Pulse sits on top to be able to do all the distributed data intelligence on top of that. Yeah.
Yep.
All right. Go ahead.
Okay. Yeah, so this is kind of like a more sort of like detailed architecture that is relevant to HiveMQ Pulse. So as you can see here, we've got like again this edge to cloud architecture. We've got the site to the left here, and we've got HiveMQ Edge, connected to HiveMQ Broker. So what you'll notice here is that we've got these sort of like more small pulse setting icons against each HiveMQ real estate. So that is effectively a pulse agent. So basically this concept of an agent, not an AI agent rather, but sort of like an agent that is able to perform compute against your sort of like your traffic, right? So you've got data that is coming out of a Modbus, device, your data coming out of your OPC from a SQL Server, database that is, you're bringing into Pulse. That agent then allows you to be able to perform some, data contextualization, transformation, normalization, and aggregation within that specific kind of like real estate. So that's why we sort of like talk about this idea of distributed data intelligence. You're not waiting until the data hits your sort of like your cloud environment before you can sort of like generate insights off of it. And then this intelligence is also available at a site level within the MQTT broker platform. So this could be a standalone, agent, or it actually acts as an extension which you can connect to a HiveMQ broker. And then what you notice that as you start to move more into the IT side of things, you do have what is called a Pulse server. So this is your Pulse server that is communicating with your sort of like your Pulse agent. And what the Pulse server does, it exposes an API that then allows you to be able to query the data, all of your data across your entire enterprise. So I'll show you what that, query sort of like API looks like, shortly. But basically what you could see from this is that now you're kind of like really moving from a situation where you need to subscribe to 100, 200 MQTT topics for you to be able to get the data that you need. And this, data is actually being generated dynamically. But here you're actually getting the data that is, from a governed namespace that exposes, a query layer. So you can then start to ask for the data that you actually need in the format that you need that data. You don't need to subscribe to hundreds of MQTT topics and then build the logic to then, you know, sort of like, build your data-driven application. Because as you may know, if the source of that, data changes, or, something breaks there, or a format in which that data is being delivered changes, then that kind of like breaks your application. But with this query layer, it means that you've abstracted your data sources from how you consume that information. So this is really, really, super important, shift from how we normally consume data from your unified namespace. And then again, you can see you have all the streaming services, data lake, all plugging into that query layer. So if you want to persist all of that data in the right context into your data lake, it's a matter of just kind of like having those, queries to your Pulse, or you want to just visualize the data, whether it's you're using Power BI, or you want to visualize it even at a SCADA or a shop floor level, you kind of like perform that query, and then kind of like build your dashboards and sort of like generate the real-time data for your stakeholders. So this kind of like just to give you a sense of, we, as Harvey, as Ravi mentioned, this is currently in private preview. We launched this in February at the Prove It conference, and since then we've kind of like been, really sort of like engaging, some different companies and different, thought leaders within the space. So you could see the response that we have sort of like, been getting so far. So you will see someone from Magna really think this is really truly, groundbreaking. And then obviously Hawk Reynolds, some of you may be familiar with, kind of like really, talks about this as being something that, is the real deal. So they kind of like gives you a sense of how excited, people are out there about, the launch of HiveMQ Pulse. Okay, so now I'll kind of like give you a sneak peek of what that looks like. So I'll kind of like first, just show you, the screenshots of, what that looks like to be able to interacting with HiveMQ Pulse, and then, maybe just quickly show you the console, what that console looks like, and how you able to navigate that console. So again, we spoke about this idea of governance, and maybe for some of you may be wondering what that looks like, right? So again, going back to this idea of a unified namespace, how we know unified namespace, or how unified namespace has been sort of like, really, been implemented so far, it has really been about devices and systems generating data, publishing it into an MQTT topic namespace dynamically, and then it happens to be in the MQTT broker, right? And this is hardly something that you can really query against, that you can enforce. So the first step is really to be able to define an information model that is irrespective of the MQTT protocol. So you define how your organization is already structured, irrespective of whether it's an MQTT topic or not. And then you start to get your sources of your data, plugging into all the different levels of that namespace to hydrate that information model with the live data. So in a way, you're creating that ontology, and then plugging it with sort of like real-time data from across your entire enterprise, or rather from all your operational systems, publishing that data into that. And then you'll notice that within this namespace, I have got what is called an agent. So if you remember from the previous architecture, this idea of an agent, in this case, we've actually got a node within the namespace that is actually an agent. So you've got a node that has intelligence within your information namespace. So you no longer have that's just the passive node. So this node is responsible for sort of like, performing some intelligence on the nodes that are under its namespace. So in this case, we've got a Berlin MQTT agent. So everything under Berlin, which is filling, filler one, filler, all of that, the data, or the computation that needs to be performed against these nodes to contextualize the data, to transform it, is handled by that specific node agent, which then makes that data available to your Pulse server, which then makes it easy for you to be able to build your analytic applications against it. Right, and then again, you can see that here we do have a publisher, node, which is basically a way that you can kind of like republish, if you've got like MQTT traffic that you want to republish into your unified namespace information model, you can use that specific node. So again, to reiterate, your information model is irrespective. And I saw, one question on the chat here that was kind of like, wanted, clarification on what it is to mean that, MQTT is kind of like not sort of like the namespace, right? So this kind of like what it means. You define your information model irrespective of MQTT, and then you could have a republisher that is monitoring your MQTT traffic and using that to hydrate your information model. Yeah, so this is the kind of like the query API. So some of the stuff that we, relating to Pulse, we did on the launch webinar. So if you want to kind of like get some details into that, check out that video. So what I want to show you now is what we have kind of like, sort of like, done so far, the milestones that we haven't showed yet. So this is, your query API. So that's just the section of it, kind of like to get a sense of how you're able to sort of like, perform queries against your unified namespace. And as I mentioned, this is something that is not currently possible with really any unified namespace implementations. So you could see here that you can actually query against a node, right? You could not only that, you can also query against metadata. So you're able to contextualize your data within your information model, and then you're able to perform queries against your metadata. And then you can also perform queries against the schema of the metadata. So there's a whole lot more things that you can do from this query API. You can also query the health of the actual agent. So I spoke about this idea that you've got this piece of compute that is performing all of that uh, intelligence generation. So you could actually query the status and the health of that specific piece of equipment. So this is kind of like what that looks like. So if you perform a query, so in this case, this is a query that we, performing against metadata. So just by, supplying that, node ID. So the node ID is something that you can get from the actual, console, the unified namespace or the Pulse console. So you supply that node ID and then, the metadata, and then this is the response that you can actually get. So now you kind of like, if you think about it, this is, this could be information that is, you are sort of like querying from a database, you're querying from a PLC, you're querying from an MES system. We are describing how you want to consume that data, and what you get at the end of the day is this object that is rich with context, with all this data that you care about. So you're kind of like effectively using that query interface to get all of the data out of your unified namespace. So we spoke about this, idea that companies lack this high quality contextual data to be able to drive their AI ambitions or data driven ambitions. No, this kind of like really a huge step towards that, because then you have got all this contextual information that is governed. It's got security and it's trustworthy. You can then start to build your business model around that. And then speaking of security, this is kind of like also an example to show you what, a security policy could look like. So you're performing security policies against actions that can be taken against a node, right? So who's able to sort of like read, a certain node, who's able to create a node, or data actions. What actions can be performed on data? Can you transform data? Can you write data? So this is kind of like rich, way of really enforcing security against your information model that makes it trustworthy. Because in many cases, you may agree with me if you're in the industrial domain that it's not really easy to gain the trust of a platform where you don't really know what secret mechanisms are in place. So here you've got this governance platform that provide that security guarantee, so they're able to really build data-driven applications off of that. Okay, so we again we spoke about this idea that the unified namespace still is as we know it, that edge to cloud architecture that consists of your protocol converters, your gateway at the edge, all the way up to the cloud, is kind of like really the backbone on top of which you're able to build your distributed data intelligence. So what we have done is you have come up with a unified namespace maturity assessment. So this is basically, a way to sort of like help you measure yourself against your industry peers on what level of maturity are you as far as having that, backbone, for data-driven manufacturing is concerned. So, you could, just use your the QR code here on the screen here for you. It will take you to the page. You are able to, in a minute, just go through questionnaire, and then you're able to sort of like get a report on exactly where you are as far as the UNS maturity is concerned. And with that, you're also going to get an architecture recommendation on what it is that you need to do to move into the next phase uh, of the readiness for unified namespace. So if
Awesome.
just want to quickly take a minute just to kind of like give you, a feel of,
Mhm.
the actual console. So Ravi, just give me a thumbs up if you can see my screen.
I can see a screen. Actually, that was one of the feedbacks. A quick demo would help. So great. I mean, if you
Oh
can
yeah,
give a quick demo,
absolutely.
that'll be
Yeah.
fantastic.
Cool stuff. So as you could see here, this is the the actual console for HiveMQ Pulse. So here you see we've got namespaces. So basically, I do have a namespace. So what that means is that you could have multiple namespace here. You can import a namespace. You can also export a namespace. And then what you're looking at here is not just some MQTT generated namespace level. These are strongly typed nodes. So and a site here is actually of a site type, right? An area is actually of an area type. So these are strongly typed nodes that you're able to then perform queries against and build metadata against. So if you notice here, I've got labels. So for this enterprise, for this node, I've got labels, which means you can actually start to add context to your data on this platform. So if you are already, if I go to this, temperature node here, so you notice here that I've got nothing here. So I could then start to create the units of measurements because we don't know what the units of measurements are for this. So you can then start to create labels or for the units of measurements here. That will kind of like really be, help you standardize all of your data across the entire enterprise. And then not only that, you're also sorry, to able to create some more advanced nodes. So here you notice that I've got a node for OEE, which is as a result of a calculation by combining or multiplying other nodes within my namespace. So this kind of goes back to also to the idea of having that agent that provides that distributed data intelligence. It then allows you to be able to generate OEE, for example, here, insights right at the source of the data. So maybe you may want to also generate things like energy usage, or you want to monitor quality, or whatever insights that you want to be able to generate at what level, whatever level of your hierarchy, whether it's on the shop floor, whether it's on the enterprise level. This allows you to kind of like distribute that intelligence again across your entire enterprise. And then here we've got the section for templates, because all these objects, as you may know, you want to be able to standardize on the object. We spoke about this idea that you want to standardize on what it is your compressor should look like, or what it is an OEE object should look like. So these templates allow you to perform that standardization. And you're not only standardizing on your custom defined, you're able to import also, whether you want to import OPC information models, you want to import asset administration shell, or you want to import digital twin definition language, you're able to import that directly into your namespace. So it's kind of like a quick view of what that namespace look like. And then here you're able to see, if I go into the agent tab, you can see here I've currently got an agent here that is not active, but as soon as you start to add your different agents, they start to show up, and then you start to see all of the information about what it is, whether your agent is on, and also, what sort of a host is that agent connected to. And then also you have alarms that you can define that you're able to see here. And then here I spoke about the API. So this is the API that you're able to query against. Yes, so I think I want to leave a few minutes here to answer some questions, but I think this kind of like really gives you a good idea of what that platform really looks like. So these are the different node types. So we spoke about the idea of having a republisher, or simply a simple object, or an alarm, or an agent, a site, asset, enterprise. So you've got all these different types, strongly typed, no, typed types that you can use across your entire information model, and then perform governance, apply security policies against, because now you've got all of this, context around it. All right,
Awesome.
so
Awesome.
let's use the last, 6 minutes of this session to answer some questions.
All right. So there's been a lot of questions. I've been trying to answer some of the questions, but maybe one theme that is coming across Kudzai is around Sparkplug B, because I think a lot of the audience are using Sparkplug B, and the question is like, how does a UNS data model, for example, relate to Sparkplug B, or whether or like Pulse can support Sparkplug B in terms of a data model.
Yeah. So I mean, so Pulse supports any sort of like, as I
Right.
mentioned, sort of like any data source, right? And as
Mm-hmm.
you kind of like may know, Spark B is effectively an MQTT traffic. So Pulse will, recognize that as MQTT traffic. However, we do have tools within sort of like the HiveMQ ecosystem that allows you to be able to transform Spark Plug. So you don't have to worry about changing your source of the data. So because typically, companies want to use Spark Plug for like, up to level
Mm-hmm.
2, for like kind of like real-time control, SCADA. Maybe you've got ignition, you're connected to edge of network nodes, to your ignition environment, you're using that for your SCADA visualization, and then you want to push that data up now to IT, and then maybe you
Mm-hmm.
want to then, sort of like convert it into maybe a JSON structure, or you want to maybe just, unpack that into sort of like fan out, because as you may
Yeah.
know, Sparkplug gives you sort of like the kind of like bundles everything under one topic. But some
Yeah.
companies want to be able to subscribe to sort of like granular, topics. So there's a whole lot of tooling within Pulse that allows you to be able to perform those kinds of transformation to sort of like
Yeah.
integrate your sort of like Sparkplug into
Yeah.
IT. So
Yeah. Yeah.
Sparkplug has its, sort of like, ambits within which it operates within the shop floor and
Yeah.
area. And then as you move to IT, if you wish, you could still use Sparkplug. Some companies find it, limiting, then they want to sort of like perform some transformations on that data.
Yeah. Hey, Kudzai, could you put that assessment slide, the UNS assessment slide up if you don't mind on your screen as I ask the next question. I think the next question related to that is like, hey, that's great. But then like when you showed me your UNS, you're kind of like showcasing that ISA 95 model of organizing the data. And guess what? That doesn't quite fit well with my Sparkplug B definitions because doesn't quite fit into that. So how do you rationalize that? I mean, is there any way HiveMQ to replicate an ISA 95 topic structure to maybe pass Sparkplug B topics?
So again, as I mentioned, we're effectively moving away from this idea that the your unified namespace, you know, needs to be an MQTT topic structure. So
Right.
whether it's flat MQTT, whether it's Sparkplug, the unified namespace, as far as we're concerned, is no longer tied to the MQTT topic structure. So effectively, your regarding ISA 95, we are free to, choose, whether you want to stick to ISA 95 or not. But the idea with HiveMQ Pulse, or our, sort of like, approach to the unified namespace, is that to say you need to define your information model irrespective of what source of data is you're using to hydrate that. So if you've got a Sparkplug edge of network node, still it will need to publish to a node within your information model that you have defined. So it's irrespective of whether you can sort of like use that Sparkplug topic to then, create a unified namespace as it were. I don't know if that kind of like answers the question.
Yeah, yeah. It does. It does. Let me see what other question that might be useful. Okay. Yeah, I guess like thanks for clarifying the difference between HiveMQ Broker and Pulse. Could you clarify the difference between Edge and HiveMQ Broker if time permits, and when to use Edge or the broker directly? I think there was a few questions. Say, do you always need the Edge, for example, to be able to talk to the broker, or can the broker directly talk and integrate with historians and other applications?
So, I mean, the reality is that, kind of like as we spoke about, in as much as we want to standardize data on MQTT, but a whole lot of systems don't support MQTT. Some PLCs support Modbus, OPCUA, and the different protocols. So the number one reason why we have IVMQ Edge is to provide that protocol translation to get your data from your legacy protocols into a common data format. So that's kind of like the reason why we have HiveMQ Edge, and it happens to go with also an MQTT broker within it that allows you to rearrange that data or arrange that data within whatever level you're working with, and then move the data into your MQTT broker. So your MQTT platform then becomes that backbone for holding all of this data. So you may have data that is originating from HiveMQ Edge from all your different PLCs, and it's going to your MQTT platform, and then you also have data that is originating from your MES system that may not be connected to HiveMQ. Maybe it happens to have a MQTT connectivity, or maybe you've got a microservice that is,
Mhm.
behind it that is doing the protocol translation into the MQTT platform. So, HiveMQ does not replace the MQTT, platform that is kind of like really your backbone as far as unified namespace is concerned.
Yes. Yeah, I think we are out of time. I think there's still a lot of questions. So what we can definitely do is we can take all these questions and answer these offline. So at this point, I think we probably, in the interest of time, we should end this session. I think this was a lot, very, very interactive. Thank you so much for all the questions. And keep it coming, right? Even afterwards, like please reach out to us on hivemq.com and reach out to us for any questions. And you reach out to me or Kudzai like on LinkedIn, right? I'm Ravi.Subramanyan at hivemq.com. Kudzai is kudzai.manditereza at hivemq.com. We're happy to answer questions as well. So thank you and have a great rest of your day, folks. Bye bye now.
Thank you.
Thank you.